Good morning, everybody. Welcome to another edition of the Lab 207 webcast. My name is Mr. Kite, and I'll be hanging out with you today as we continue on in our discussion of ecology. Topic for the day is going to be human population, so let me get you your objectives and we'll get going. By the end of this video, two things you should know or be able to do. The first one is to describe human population growth and the demographic transition, and the second is to explain the concept of carrying capacity in relation to the human population. So today's all about human population. We're going to talk first about how the human population has grown over time. We're going to talk about some models that are used to predict the future of populations, and ultimately we're going to talk about human population in relation to the carrying capacity of the earth. So that's what we got. Let's start out with a quick discussion of how the human population has grown over time. Through human history until sometime in the mid-1600s, human population stayed pretty stable with a high number of births but also a high number of deaths. No real change in the human population until the 1650s, when we started to see an increase in the quality of life for people. So 1650, you got 500 million people on the earth. Jump forward 200 years and we have doubled the population to 1 billion people. And then after this point, things really start to pick up. So jump forward a short 80 years, you have doubled the population again to 2 billion people. Jump forward another 45 years and we are at 4 billion people. And here we stand in 2013 at 7+ billion people. So human population grew exponentially for quite a long time. It peaked, peak population growth rate was somewhere around 2.2% per year in the 1960s. It's since decreased to 1.5 to 1.7% per year, which is still a very rapid growth rate, but it looks like the human population has stepped off of the exponential part of the graph. Now, talking about human population growth, I want to introduce you to a model called the demographic transition. And the demographic transition basically talks about how population growth in a country changes as the development of that country increases, going from the most basic rudimentary of society all the way up to a highly industrialized, very advanced society. So let me walk you through this a little bit. There's some very interesting things that you can see. So in a stage 1 country, and this is represented by a few remote groups probably living as nomads or in the deepest jungles. In a stage 1 society, you've got a very high death rate, black line, and a very high birth rate. And your total population isn't growing very quickly, because the idea essentially is that if you've got a lot of children dying off, you also need to have a lot of babies to replace them. So things stay pretty, pretty even. As that country starts to develop and becomes more advanced, they're known as an early expanding society. Examples of this: Egypt, Kenya, India. In this part of the demographic transition, we see the death rate starting to decrease quite dramatically because the quality of life is improving, sanitation's improving, medicine's improving. So people are dying much less frequently. However, culturally, people still think, hey, I need to have a lot of kids in order to make sure that they make it into adulthood. So though death rates decreasing, the birth rate is still pretty high, which means that your population is going to start to grow pretty rapidly at this stage. Now, at a late expanding country, the death rate has fallen quite a lot. We also see the birth rate starting to fall off. So this is where culture starts to catch up with the reality of death rate. Also in this phase, you start having development for women. You start seeing family planning options coming in. So that's what's taken our birth rate way down. And because birth rate still is fairly high and the death rate is pretty low, we're still increasing our population pretty rapidly. And then stage 4 country, which is most of the developed countries in the world, you got US, Japan, France, UK, the population growth has pretty much leveled off because your birth rate has come down, your death rate is pretty steady, and your population essentially has stabilized. And then right out here, stage 5, demographers are still waiting to see whether there is truth in this model, but it's possible that these types of countries, the birth rate has actually fallen below the death rate, so they are below replacement level fertility, and the population is actually declining. An example of this would be Germany. Some Eastern European countries, Japan, are seeing this sort of transition presently, where their population is actually starting to slowly decline. Another model I want to show you that demographers use to kind of look towards the future of a country. It's called an age structure diagram. And an age structure diagram is basically a breakdown of the population in a country where you've got this graph split in half, males on one side, females on the other side. It is broken up by 5-year age blocks from birth all the way up until 80 plus years of age. And the bottom is the percentage of the population that each bar represents. So you can see right here, this pyramid shape is seen in a lot of developing countries. And the thing that demographers can tell from this sort of pyramid is that the population is going to probably grow very rapidly going forward, because the bulk of your population, you can see the bigger part of your graph, is down here in their pre-reproductive and early reproductive years. So all of these people right here, as these chunks of the graph move up, they are going to leave bigger pieces of the pyramid behind them, because all of these babies are having babies. So you're going to see rapid population growth in this sort of age structure. United States is an example of a fairly stable age structure diagram. Now, one thing to note with America that we currently face is we've got a large portion of our population right here in the middle. This is the baby boom generation. And as they move up into their older years, they're going to leave a smaller proportion of I guess, Americans below them. And with social structures set up the way they are, these working age people are paying into the social support systems that are taking care of this older generation. So a lot of people worry that since the older generation is a bigger proportion of the population than the younger generation, the programs that take care of this generation may not be financially viable. And then in a declining growth model, you can see something that looks like this, or even kind of like an inverted pyramid, where you have got the largest proportion of your population up here, smallest proportion down here, which tells a demographer that the population of this country is going to be declining over time. A couple other qualities of population that demographers talk about is the quality of life, and that is basically looking at the infant mortality and life expectancy. So how many babies make it past the age of 1 or 2 years, and how long can a person expect to live? Now, the map there on the right is showing colors based on expected life expectancy, and red is a very poor life expectancy, green to blue is pretty good life expectancy. So in countries that are developed, they got a lot of medicine, a lot of opportunity. Infant mortality is going to be pretty low, and life expectancy is going to be pretty long. Now, in a country that doesn't have some of those structures in place, a less developed country, infant mortality rate is going to be pretty high, and life expectancy is going to be pretty short. So, based on the development of the country, demographers can tell a lot about the quality of life based on the life of a baby and the life of the individual as a whole. And kind of finishing up here, demographers talk about carrying capacity. All these things that I've talked about so far are looking towards carrying capacity, which is basically the question of how many people the Earth can support. And there's a lot of argument that goes around about what will actually limit the growth of the human population. Will it be water? Will it be space, food, non-renewable resources, general conflict, the ability to get rid of waste? We don't really know, but we do know from studying populations that every population on Earth has some sort of carrying capacity, and human population has been able to rocket forward in growth for so long with our ability to advance technologically that we're not quite sure where the carrying capacity for the human population is. It's something that is still an active debate. And one of the things that people use in this debate about carrying capacity is ecological footprint. And ecological footprint basically talks about the land area and water area needed to support the lifestyle of a person. So that would be provide resources for the goods they consume, food, energy, also provide space to get rid of the waste. Now, if you take the land that is usable for all of these purposes around the world divided by human population, it says that there should be roughly 1.7 hectares of land per person. In some developed countries, such as America, the average person uses roughly 10 hectares of resources. So, based on where you live, your I guess consumption and ecological footprint is going to be much bigger than if you live in somewhere that is less developed. And this imbalance is one of the things that drive questions about the carrying capacity of the Earth. So I hope that that was a little, I don't know, I guess it was a helpful tutorial for you on basic concepts of the human population, its growth and sustainability. Thanks for joining us on the Lab 207 webcast. My name is Mr. Kite, and we'll see you again.